This tutorial is for users wishing to take advantage of the boost in processing speed for base SAS programs that will execute in SAS Viya. Hi, I'm Charu, an instructor with SAS Institute. Here's a little background on me. You can also find me on blogs.sas.com. On the agenda today, we'll cover 3 topics. I'll first show you how to connect to CAS, and then we'll load data to a Caslib and process it in CAS. And finally, we'll modify SAS code to run in SAS Viya. So what is SAS Viya? SAS Viya is the latest enhancement of the SAS platform, open, cloud-enabled, analytic runtime environment with a number of supporting services, one of which is CAS, or SAS Cloud Analytic Services. Question that is probably top of mind: is SAS Viya a replacement for SAS 9? I'd like to assure you that no, it's not. You can still leverage your SAS programming knowledge and make tweaks to existing SAS code to allow it to run in SAS Viya. And we'll see an example of this in section 3. In the tutorial, I'll log in as Lynn, a SAS Viya user. We'll see the world from her eyes as a data manager. I'll use SAS Studio as my coding client to modify existing base SAS code to run in CAS. Now let's get started with a demonstration. In section 1, we'll connect to CAS to enable data transfer between SAS and CAS. Let's start with what we already know about libraries. As a SAS programmer, you're likely familiar with SAS libraries and the LIBNAME statement. Here, for example, you have a folder which contains various data types, including SAS datasets, CSV files, Excel, etc. In order to access the SAS datasets, we'll associate it with the folder. So here's a LIBNAME statement pointing to this folder, and the library is my SAS. In CAS, we also use libraries, but they are called CAS libraries. The CAS library, or Caslib, is the manner by which data is accessed in the SAS Viya environment. At its simplest, a Caslib is really a container that has 2 main areas: an in-memory space where the processing takes place, and a data source. In the data source, we might include SAS datasets, CSV files, databases, or SAS H.dat files. Here is a session called My Session that we've invoked, and we'll see an example of this in the demonstration that will follow this. Let's get started with our first demonstration. I'll launch Google Chrome from the desktop. Then I'll click the SAS Viya tab below the address bar and choose SAS Studio. Once Studio launches, I'll go navigate to my folder structure, and within there, I've already created a shortcut to the folder where I have my data and all the exercises. I'll double-click to launch the exercise that I'm interested in, the very first one, where I'll be doing the connection to a CAS server. So even before we connect to the CAS server, there's some terminology that we would like to be aware of. And the terminology alludes to SPRI versus CAS. So CAS is Cloud Analytic Services. SPRI is our foundation SAS, which, as we all are familiar with, it is the long-time workhorse. It is where we have our foundation SAS software that we use, our SAS access engines. So let's begin with executing something in the SPRI. So we'll understand that and emphasize that we do have an independent SPRI session with its own capability in CAS. So here is my LIBNAME statement. I'm assigning a library called My SAS, pointing it to where my data is sitting. Submitting this code, I use the F3 button. And on the right side in the log, I'll confirm that the library was successfully assigned using the V9 engine. To validate further, I'll click on the libraries icon on the left side, and I should see my SAS assigned there. However, we don't see any of our Caslibs, and by default, Caslibs don't show up in the tree of SAS libraries. We'll be learning to do the assignment of Caslibs in the next exercise. Next step is to start up a CAS session. We'll call it my session. And here are some defaults using the CAS statement. The library is CAS user, and I'll submit this code. Once again, I'll validate that the CAS session, my session, connected successfully to Cloud Analytic Services. And all of this hasn't assigned any CAS libraries yet. We'll be doing all of the assignment in the next exercise. In this exercise, we will be assigning or accessing Caslibs. First and foremost, we'd like to see what are the libraries in my CAS session. This statement, Caslib underscore all underscore list, will do the trick. So I'll go ahead and submit this code. In the log, as I scroll up, I'll notice that the session is my session, and within that, I have different libraries. Here is CAS user. As I scroll down, I see a library called formats, another one called models, yet another one called public, and there's one called samples. There is only one active Caslib in CAS, and by default, that is going to be CAS user. I validate that with this statement, active equals yes. This option indicates that this is my active library. If I wish to change it from CAS user to another library, and we'll learn how to do that in a later section, we can do one of three things. We can change the active Caslib in the statement, or we can create a brand new Caslib with the same statement, or we can drop a session scope Caslib, and that is something we learn about in the next session. Furthermore, now that we have got a listing of the libraries, we can go ahead and see the files that are within the default CAS library, which is CAS user. So I'll submit my proc CAS util step with the list file statement. The results as I go further down will indicate that there is one Excel file, sales.xlsx, in this CAS lib, and the log will also validate the same. CAS has processed the combined requests, and the name of the file is sales.xlsx. I'll return to the code tab, and I'll now go ahead and use a Caslib statement to create a new Caslib called my CAS. I'll check the log and verify that my CAS is now the active Caslib, and Cloud Analytic Services added this Caslib. I'll go to the libraries icon and try to see if I can find my CAS there. And the my CAS library is not visible. Again, by default, Caslibs do not show up in the libraries tree. We need to submit a Caslib statement such as this one here, Caslib underscore all underscore assign, in order to see those libraries show up in the library tree. So I'll submit that. There are a bunch of notes in the log, and in the navigation pane, now I should definitely see CAS user. I should see my CAS, the CAS library that I had just assigned. Now I'll see in the listing, if I resubmit my Caslib underscore all underscore list statement one more time, in the list of libraries, in addition to what I saw earlier, all of the libraries such as CAS user and formats, it's all stuff we saw earlier, we should also see my CAS. It should say that this is active, And the one difference from the previous libraries is this option, local equals yes, indicating that this is just a session level Caslib. And what does that mean? That means this definition goes away as soon as my session ends, and we will have to redefine it in a new session. We'll return back to the Code tab, and we'll submit one last piece of code. This is a proc CAS util step, and within that, I have a list table statement and have a list file statement. So it might be useful to just step back a little bit and understand the difference between these two. What files means is file is the word that's used to refer to the source data in a Caslibs data source. Table, on the other hand, is used to refer to in-memory data. So we like to see both the data sources with the list file statement, as well as the in-memory data with the list table statement within the MyCAS library. So I'll go ahead and submit this piece of code. And in my MyCAS library, I'll see a couple of files in here. In the file statement, it reveals that I have an employees data set as well as the products Excel file. We don't see any information about tables. And we can further validate this with the statement. No tables are available in Caslib, MyCAS of Cloud Analytic Services. However, the two files were visible. Next, we'll see how to change the active Caslib. I'll head over to my folder structure, and I'll open up the program where I have the code for changing the active Caslib. So once again, there's only one active Caslib in CAS, and I pointed out earlier how you could change that Caslib. In the last exercise, if you recall, we had made MyCAS the active Caslib. We'll make CAS user once again my active library by going ahead and submitting this CAS statement. And I'll verify that MyCAS is no longer active and that CAS user is my active CAS library. How do I change it from this one to yet another library? I'll go ahead and submit the CAS statement, providing the session details. And in the Caslib option, I'll provide public as my library. I'll go ahead and submit this code, and I'll say, can you also please list for me the public library? So I don't want to see every single library listed. And here, the note in the log says this is the active library. The name of the library is public. That was the first way of changing an active Caslib. For our second way, we'll turn back to the Code tab, and we'll use a Caslib statement to assign a library called MyPath and provide the path. The path itself is a Linux path. And also we'll supply an assign statement right after creating the library. How can this be useful to Lynn? This creates a session scope Caslib called MyPath. And a session scope means a library that is active for this session. It's a great solution for Lynn if she needs files for ad hoc processing and reporting, and she really doesn't need to hold on to these files after the fact. So I'll submit this code. And check out the note in the log that says, my path is now the active Caslib. At any point in my session, in my program, if I wish to validate which one is the active library without having to put these statements down, without having to put this assign statement or the list statement down, I can certainly use a %put statement, active Caslib equals, and use the get SAS opt function that writes out the name of the active Caslib in the log. And this way you prevent all the additional information that you're bound to get with the Caslib and the list option. So there in the log, it comes back and reports that the active Caslib is my path. The third technique for modifying an active Caslib was the drop statement in your Caslib statement. So I'll submit this. And as a result, it reverts back to CAS user being the active Caslib. In section 1, we learned to connect to CAS, we learned to access Caslibs, and we learned also how to modify a Caslib. In section 2, we'll learn how to load data to a Caslib and process it there. So firstly, we learn the difference between session scope and global scope. Then we load client-side data into Caslibs. And thirdly, we load server-side files into CAS and promote tables. In-memory tables can have either session or global scope. So what's the difference? In-memory tables have session scope by default. A session scope table is only accessible in the CAS session where it was created. It's only visible to the user who created it. So where is the use? Session scope tables are useful for ad hoc data access and analysis. It only exists for the duration of the session. When the CAS session ends, the table is dropped. But what if you need to share data across your sessions or with other users? You must create a global scope table in order to share data. It's also called a promoted table, and we'll see examples of this in the demonstration. Second, we'll learn how to load data into memory in CAS. We'll be logged in as Lynn. Files of any kind that are not mapped to the Caslib are called client-side files. We load files into the in-memory space in CAS using our client software. In our case, we'll use SAS and proc CAS util. And lastly, we'll learn to load data into memory in CAS with server-side files. So we've already started a CAS session, we've accessed a CAS library. Now we wish to update or analyze data. CAS can only process data in its in-memory space, so the next step is to load data into memory. Source data files mapped to a Caslib are called as server-side files. These can be rapidly loaded into the Caslib's in-memory space for processing. So if we need to load a server-side file that is stored in the Caslib's data source, we'll use a CAS util load statement with the CAS data equals option. In this demonstration, we'll see the difference between session scope and global scope, something I shared with you in this slide presentation, and we'll see that in the demonstration itself. So we'll see how by adding the promote option to this statement, what it does to that table versus not having the promote option. First, the scenario here is we'd like to load my SAS.employees into Lynn's personal Caslib, which is CAS user. And Lynn is going to create an in-memory session scope table. It's a table that others will want to access. And when Lynn is happy with that table, she will use the promote statement, which is what we're going to use here, to create this table as global scope so that other users can use this in-memory table. To begin, I want to first use a drop table statement. And in case the data already exists, I want to delete it. The quiet option is needed to prevent the error. If the table doesn't exist, you're not going to get an error. Once that's done, I want to submit my proc CAS util statement to load two tables, sashelp.cars and also my SAS.employees, and the difference being the promote option. Once I submit this code, I'd like to answer two questions. The first question is, what is the table scope for my cars in memory table? And we can verify that by running this list table statements. In the log, I'm going to see the two tables displayed, and I'm going to see some information there that is quite interesting I'd like to highlight to you. The MyCars dataset, there's a little bit of my metadata here in terms of number of rows and number of columns. In addition, I'm going to see that the MyCars table is not promoted and the My Employees table is promoted. And we'll see what that means to us as we go further down. I'll terminate my session, and then I'll take a look and see which tables are available to me in my CAS user library. I'll rerun the program that's going to invoke and connect to CAS. And I'll head back to my libraries. Oh, and I also need to remember to assign libraries. You remember, it's not just enough to give a connection statement. So for that, I have a program already here called startup.sas. And in there, I'm going to assign my CAS session, my libraries. Once I've done that, I'll head over to my libraries, expand CAS user, and there, as expected, I'll see my employees. So to recap, go back to our code. What did we do here? We loaded two data sets, one of which we promoted. And then we saw that this table showed up as global scope. The other table was local scope. Then we ended the CAS session and restarted it. We noticed that the table that we promoted was still available to us session after session. Let's build on what we just learned, and let's go ahead and load client-side data into CAS. In addition, we'll also see how to explore metadata. The first thing I want to do is load the client-side SAS dataset, mysas.employees, and mysas is a local SAS library. We want to load this into a CAS table in Lynn's personal Caslib, and then we want to investigate the contents of this in-memory table. This proc CAS util step will do the trick. So verifying in the log, mysas.employees was successfully added to Lynn's CAS user. I'll verify by going again to my libraries icon, and I'll see there the table called My Employees. I'd like to list the tables in CAS user with the list table statement. And in the log, I have some metadata information in terms of number of rows, columns, index columns, when the data was created, when it was last modified, is it promoted or not? And you'll see that the table that we promoted, My Employees, is still showing up as promoted, whereas employees, we didn't add the promote option, doesn't show up as promoted. I'd like to add another table, sashelp.cars, into my Caslib, which is CAS user. So CAS user should now have three tables in there, one of which is promoted, and the other two are session scope and not global scope. I can also, once again, I don't have to just check the libraries icon. Through code, I can also verify what tables exist in CAS user. Again, the log has its three tables show up, and two of them are not promoted, which means they are available for this session only, session scope, and one table is promoted, so that's global scope. And if you look at the list table statement, it's sort of similar to our metadata procedure in Base SAS, which is proc contents. So I'll execute proc contents with the underscore all underscore no DS or no descriptor option. And proc contents gives us similar information about the tables. I'd like to see some more. I'd like to look at the descriptor portion of the tables in the CAS user library. So I could use proc CAS util, and I could use proc contents with the var num option. I'm going to execute this code and then expand out my results tab to see and compare the differences between the descriptor portion for the two procedures, proc CAS util and proc contents. So here is my CAS util procedure. In there's some interesting data here. The type of the variable shows up as double or char. For the contents procedure, the type of the variables, as we know from SAS, shows up as numeric or character. So what was the difference? SAS Viya has additional data types. The data type double maps onto a SAS numeric data type. SAS Viya also supports char, which is a SAS character fixed with data type, and the varchar data type, which is a variable length character field. Moving further down, I'd like to drop the tables, my employees and my cars, from the CAS user library. And when I see my CAS user library this time, I should just see my employees listed there. In the previous demo, we saw how to load a client-side table into CAS user. Now we'll see how to load server-side files into CAS and promote tables. So there is this Excel file, sales.xlsx. It's in the data source of Lynn's personal Caslib. What Lynn is going to do is create an in-memory session scope table and investigate the table's descriptor portion. It's a table that others will need. So when Lynn is happy with the contents, she'll use the promote statement to create a global scope table in the public Caslib, a different Caslib, so that it's accessible to everyone who can use the in-memory table even after the session ends. We'll first go ahead and drop this table if it already exists. Using the quiet option that we saw earlier. Then we'll use a proc CAS util step to load sales.xlsx into CAS user using the replace option, and we'll call it sales.xlsx. Then we also want to check the contents out of this table. And in the results tab, I can verify the contents of this table. Sales.xlsx is the table name. Here's the number of rows and number of columns. In addition, I'm also going to see that this is not a promoted table, and we know what that means from the previous demo. We also see something interesting here. We'll see that the character data types in sales.xlsx were converted to varchar. Lynn is now happy with this table, and she can now run the next proc CAS util step to create sales.xlsx as a global table in the public library. We'll also list the table after that. So what kind of things are we looking for now? In the contents, we're looking for the table called sales.xlsx. We're also looking for the fact that this is a promoted table. Is it in the public library? Just a matter of heading over to the libraries icon, expanding my public Caslib, and I should see sales.xlsx listed there. In the previous section, we learned to upload data to a Caslib and promote tables. In this final section, we'll learn to modify SAS code to run in SAS Viya. The first part is the SAS data step. Does the data step syntax work for in-memory data in CAS? And yes, it does. We just need to consider whether the data is processed in a single thread or multiple threads. So if we consider base SAS data step, when it's executed in base SAS, it runs in a single thread on the SAS workspace server. Processing data in a single thread reads data sequentially, one row at a time. SAS Viya enables data to be divided and processed simultaneously on multiple threads. When a data step executes in CAS, each thread executes the program statements on its data, returns the results to the controller. In the second part of this section, we learn in the data step to modify new variables. So as you already know, in the data step, we use it for manipulating data in preparation for analysis. We can modify existing values, compute new variables, conditionally process the data, and combine tables in the data step. To modify the data step to run in CAS, sometimes it's as simple as modifying the library reference on the data statement. Here, for example, I have a data step where I'm building a table called departments in CAS user using my customers, and I have a select statement doing some conditional processing. If the continent is Africa or Asia, then department is going to be general shoes. If it's something else, for example, North America or Europe, department is going to be women's shoes. We also at the bottom have a statement that says if it reaches end of file, then underscore thread ID is the value I'd like to see, and also underscore n underscore, which is the iteration number of the data step. And lastly, we'll modify a data step code to run in Viya by using the by statement. You can certainly use a data step to process data within groups, and we know that the data step must be first sorted, and then you can use a by statement and first dot and last dot processing to identify the first and the last in the group. Sorting can be very resource intensive, especially with large data sets. Default behavior when data is loaded into CAS, distribute the input data based on the original order among the different threads or multiple machines. When we add a by statement to the data step, the rows are group based on the first by variable and then distributed across multiple threads or machines. Proc sort is no longer required. Results are returned as each thread finishes processing. Here, thread 3 processes the data step, returns the results first, and the order might be different each time the program executes. So let's head over to the demonstration to see each of these three topics. Let's get started with our demonstration for section 3. First, we'll run a data step in Base SAS and compare it with SAS Viya. A few pieces of syntax that would be helpful, which may be new to you. We'll use the SAS ref equals dataset option to force the data step to execute in SAS Viya. And then we'll also be using two automatic variables, underscore thread ID and underscore n threads underscore. And this is going to give us respectively thread usage and thread count. So here is a base SAS data step. We'll execute this and examine the log. Thread ID value is 1, which indicates the data step processed in SAS is single-threaded. Underscore n threads underscore has a value 1, which indicates that there is one thread available in Base SAS for processing the code. We'll next highlight and submit the CAS statement to start the CAS session, if we haven't already started it, and assign the SAS library reference to Caslibs with the Caslib statement. Next, I'll highlight and submit the second data step. This step creates the CAS user.threads table in the CAS user Caslib and runs the data step in the CAS session. The first statement in the log confirms that the data step was executed in CAS. One of the big differences that you notice is the fact that underscore thread ID has different values for each row in the log. Threads operate independently. Therefore, the log messages were generated by each thread at slightly different times. Values represent the thread that the data step was executed in the CAS session. There are 16 threads available. Underscore n threads underscore has a value 16. In this execution of code, thread 5 completed the execution first, then thread 10, and so on. If you run the program multiple times, you might get a different order each time that the program runs. This is exactly what we want to happen when a program is executed in multiple threads. Otherwise, the performance gains by threading are lost if the data step were to somehow synchronize the output. In this next demo, we'll modify a data step code to run in SAS Viya by building new variables. So here is a base SAS data step program that creates a new variable conditionally, the variable called department, using select and assignment statements. We'll modify the base SAS data step to run in multi-threaded environment in CAS. Before the program can run in CAS, we'll ensure that the table mysas.customers is loaded into CAS as global scope table myCustomers in Lynn's CAS user Caslib. So here is the code that first is going to drop the table if it exists, and then we'll load it and promote it to global scope. Once that's done, we'll head over to the data step. And this is really familiar data step code. We have the end equals option on the data step, which allows us to track the last observation, the end of file. And when it hits the end of file, and by the way, this is a binary variable, it can only have a value of 0 or 1. The switch of 0 says, doesn't hit the end of file. The switch of 1 says, yes, I've hit the end of file. So only when I've hit the end of the file that I want to see the values of these two variables. We'll go ahead and submit this code. What we're doing here is selecting continent as the variable that we wish to conditionally process. If the value of continent is Africa or Asia, we want to set department to general shoes. If it's something else like North America or Europe, we want to set department to women's shoes. And if it's none of the above, then we want to set department to unknown. Once we execute this code, we like to see the value in the output data tab. What's the first value for city in worked out departments? You're going to see Leinster in the data step. In the log, we're going to see underscore thread ID has a value of 1, underscore n underscore has a value of 951,669. That's the number of observations that were read from the data set. So what we know of the data step is mysas.customers has a little under 1 million observations. When executed, the original program runs on the SAS workspace server in a single thread. I'll return back to my code tab and I'll submit the second data step here. This is as easy as it gets. In terms of modifying your code to run in CAS, you just replace the data step, the library, with CAS user on both the set statement and the data statement, if that is how you wish to bring up your data. I'll submit this code, no other change except on the data statement and the set statement for the libraries. So now we're going to see a little difference here. The data was distributed across 16 threads, but even before we look at the log, let's look at the output data. In the output data, this first record, the first observation, has a value of Paris for city. Remember in the data step, base SAS data step, we had Leinster. Let's head back to the log. In the log, we'll see that the data was distributed across 16 threads in the CAS session. The results were returned as each thread completed its processing. Thread 5 completed after processing 60,000 rows, and then thread 16, and then thread 12, and so on. If you were to add up the values of underscore and underscore, the sum would equal 951,669, which is the total number of rows that were read from the CAS user.mycustomers dataset. In this last demo, we'll modify a base SAS data step to run in CAS with the by statement. So the business scenario runs like this. We would like a table that includes the total cost for each continent. The original base SAS program uses a by statement. We'll modify the base SAS code to run in CAS. So down below, I have my proc sort step. I'm sorting my SAS.customers by continent, and I'll proceed to submit this code. Once I've sorted my data, I know that I have the ability in the data step to add a by statement and turn on first dot, last dot processing, something we really appreciate the data step for. We're able to get very granular and look at row level data. So if I'm the first in the group, I can use first dot continent and do some conditional processing. If I am the last in the group, I have the ability to do some other work. So in this code, I'll be reading customers. I'll be setting on the by statement to turn on first dot, last dot processing. And then if I'm the first in the group, I'll set my total cost to 0, my accumulating variable. Next, I have a sum statement adding up to cost. And if I'm the last in the group, then I wish to write it out. I'll go ahead and execute this code. And in SAS Studio, when I open up the Output Data tab, I'll see that I have 5 rows of data, and the values are ordered by continent. I'll proceed to go to CAS now. I'll first drop the table and load it again. Once that's done, there isn't a lot of difference in CAS code other than modifying the library names here on the data statement and the set statement. I'll highlight this code. And once the code executes, I'll head over to the Output Data tab. And this time, I'll see in the grid down below, the results for total cost are the same, but the rows from CAS are not returned in sorted order by continent. So what happened there? When SAS programs are processed in CAS, the default behavior is that the data is distributed across multiple threads, and the program is executed on each thread simultaneously based on the order of rows in the source table. You don't have to pre-sort the data to use the by statement in a multi-threaded CAS data step. CAS performs implicit ordering on by variables. For any questions in the tutorial, feel free to reach out. Thanks for watching.